And right now, Dr. Jassim Haji will talk about the use of AI on the Middle East and in oil and gas sector. Bahrain is trying to become a world leader in technology. Apart from mining, this country is actively using AI in healthcare and urban planning. In July 2024, Bahrain opened a Saluna MD company branch that focuses on the AI-driven healthcare solution. Jassim Haji, please. CEO of AI Society, Executive Advisor for AI and Data Science, named after Nasser Jassim Haji Sheikh, AI and oil and gas industry, and the experience of applying AI in the Middle East.
It's a pleasure to be in Moscow for second time within 2 months. So I'm coming from Bahrain with the background of artificial intelligence, but also our bread and butter is oil and gas. So I'm putting both together to try to share the experience today about the AI in the industry. So when we start talking about the AI and industry itself, we go back to the leaders, to the inventors many years ago, that we did not envisage that they were coming up with ideas for 1,000 years ahead of us. And we all think that this AI is a phenomenon of the last 50, 60 years. So now if you go back to between 782 to 844, that's like 1,300 years ago. This gentleman, Muhammad al-Khwarizmi, he in Baghdad invented algorithms. The algorithms that we talk about today is his invention. And if you go back to his books and look at the principles of the algorithms, it's not much different than what we see today. His vision was to use algorithms at the time for the calculations, for the math, for creating angles for the calculations that may come up at the time or 100 years later. So when Americans went to the moon, and Russia and others, they used his calculations, his algorithms, to be able to reach to the destinations that needed an accurate forecasting. So even his algorithms was aiming at the industry. It was aiming at the space. So the problem he had with his students, obviously, he had a lab called Dar al-Hikmah at the time, was he could not have the machines that we have today, like the GPUs, to be able to process it. So it took him weeks and months to write up some of them. But he had the principles that we come up today. Now, apart from that, there was another invention, which is robotics. Again, we think that robotics came out of Tokyo Expo, and this is something recent. But this gentleman also, Jazari, about in year 1150, he invented the robotics. He invented how the robotics were used to bring the water on the top of the surface. He had put clocks under the water, and he used it in many calculations. His most famous one is called elephant watch. But he also used electromechanical over nearly 850 years ago. That was the principles of what we see in robotics today. So the combination of the algorithms of al-Khwarizmi and the robotics of al-Jaziri brought into horizon many hundred years later what we do know, AI in the industry and electromechanical. Obviously, many years later, we had, in 1956, Americans came up, Professor John McCarthy and others, writing the same theories in the universities in US to bring up algorithms, but they had the similar problems. They had the theories, but they didn't have the machines. So that didn't go far. So basically, it was replication of the problems that happened many years ago. And then until 70s, 80s, and you know the rest of it, that probably the AI that flourished in the last decade or so, but maybe November 22, the Gen AI that came up with OpenAI, that was an eye-opener for everybody. But maybe an eye closer on many other things that we have in the industry that we cannot continue using it. So when we talk about the techniques of the artificial intelligence and what we use today in the industry itself, there are many aspects to it. These aspects are, part of it is machine learning that is predominantly and traditionally used in the industry because you require so much of the accuracy. And then you have the deep learning when we go into the layers after layers to be able to communicate with the humans. But the same layers we also use in the industry when we look at oil, for instance, reservoir, to go from one layer to other layers, and the reactions of the earth. So when we look at the constitution of how the earth is made and the depth in it, we resemble it to the human depth. So layer after layer. And this is where the deep learning goes into the part of it, but also Gen AI now, as we will see in a few examples, how in the industry that has revolutionized it. So the Gen AI that we see that is most popular for traditional or personal uses, how these are affecting the industry itself. So the integration of the industry, as you would know, I won't go through them many years ago, and from the industries from starting IR 1 to 3 to 4, I think up to industry 4.0, we're just getting hanged up somewhere in the past few years. People don't know what to do with it. They have AI as a part of it, and they have IoTs and others, but most of them are not coherently touching each other because some of those elements in the industry 4.0 are becoming obsolete, and some are taken over by AI and the large language models. So that becomes a name that by itself is an obsolete. So the industry is, I think, moving forward, is very reluctant to go industry 5.0 and what would they want to put in that. So this is why the industrial field is so important for us, and how these things are moving to the sustainability, to the goals that's related to the field, how we can increase the safety. Every now path that you put in the industry, and I'm talking about the oil and gas, but it resembles and everything else, it has the same traditions, the same parts that goes from one to another. And you're talking about industries that has tens of thousands of employees, if not hundreds of thousands. So how this is really becoming a part of the engineers. And one thing we should understand, that in the industry, AI becomes unlike what we are traditionally used to have data scientists and AI engineers developing. The people in the industry, they do not have time, or they do not want to have a shadow technical person in the AI providing them with the feedback. They want to be able to do it themselves. So that's why things like low code, no code is provided now to the industry engineers, and this is what we do. So the engineers can develop their own AI tools moving forward. Now, I'll give you some examples today, and these are not theoretical examples. These are not what is written in the ChatGPT or on the Google. These are what we have implemented and what we've seen. And I'm telling you the real-time experience in the industry by itself. So now I'll go from the large language models. The large language models is by itself is a revolution within AI, is an AI within AI. It is going to develop what we have seen in the computer visions, with the cameras, with predictions, to bring another layer of the consistency, and it can bring you the compliance, the safety. It not only looks at the data that you have trained in the traditional AI, but it goes and explores the data in the open and probably closed LLMs. And I'll come back to what is closed and open large language models, because these are how the power is moving. Of course, an AI-powered drones, this is something I think the next speaker will be talking about, but that is also transforming. But are the drones with the computer visions something of the past? That's a question that I will pose. I think it is, because now drones with the large language models can provide you with the better results and the wider options. It can resemble immediately the captions from the computer visions to LLM visions. LLM visions can identify the pictures with what is available and provide you. It does not have to go and search with your own parse. And this is where we're coming to the computer visions. The computer vision is still utilized. It is more of tighter communities of what you have to provide. But I think soon that terminology will be also replaced. I'm talking about current and futuristically. When we go back to the IoT devices, and again, smart factories, energy management, workers, the interconnectivity, it is still used because you still require sensors. This is probably for the magnitude or the number of devices that you require. Sometimes you need to be focused on main factory elements, but sometimes you have tens of thousands of locations. What do? You cannot put smart cameras in each one, because of the cost, because of the accuracy. So you probably compromise that with the IoT devices or the sensors. Now, sensors also, they go back to the large language models and identify themselves within the weaknesses that they have. So if we find out itself that the sensors in certain areas are not performing, it will go back to the other ones. We'll come back to the robots, and that's robotics. Robotics also that has been used traditionally in the industry is disappearing. What are the robotics? Robotics that are used for repeated tasks. The robotics that are used with IoT, with others. That is something of the past. Now, robotics without the intelligence, again, I'll go back. I know you're going to get sick of repeating the LLMs, but if it does not be incorporated with the LLMs to be able to bring the intelligence to it, that will not be sufficient for the industry as well. So again, the optical character recognitions, what is known as OCRs, these are also recognitions for the very specific parts maybe in the industry. This is used mainly in the warehouses where you need to identify so many of them as we move forward. I mean, some even trackings nowadays is multiple technologies. When you want to track, for instance, an oil barrels from the factory to the sea, to do that within the factory, maybe you use IoT devices or you use some OCRs or QR codes. But once they go outside, then you need to use a different technology to be able to track them, and then so on until you get to the ship. So I'll give you some clear examples on, and very quick ones because of the time. So, you always have the upstream, and then you have the downstream and so on. So the upstream, the explorations and the drilling and the outcome, it's very much done on the predictions of the data or the large language data that is provided, also on the reservoir. So now the cost that has been put in the industry for the upstream, of course, is lower than when we go to the reservoir management, when we go to the deeper drilling. And as I said, when we go to the safety of, when we talk about safety, there are two elements to it. One is the safety of the employees, the engineers that are roaming around, and majority of the human resources in the industry are unskilled. These are the people who do not, probably in that part of the world, do not know how to read. They do not know how to follow. So what do you need to guide them to that? And this is where AI comes into the recognizing the faces, the badges, the helmets, the wearables. The wearables are becoming very much into that, and also into the emergency response times and the direction that they have given. So demand for forecasting, again, and smart grid optimization. This is very much part of the utilization. So how do we use, for instance, AI to do the most common optimizations? And these are according to the demands and based on the data that is available. For instance, the oil and gas itself is very rich. When you go into for instance, the data that you want to use in the healthcare, you tell me how much of the data you have that you can go back, and how much of the variety of the data that you can use, and what are the privacy that is due with it. The oil and gas, luckily, we don't need that much privacy in it because the data is available. We also have rich data. For instance, in my country, we have 80 years of data. Imagine 80. Now, you tell me which industry you can get that much of a data. You know, apart from the counting of the dead people, you don't have data for anything else. But in the oil and gas and those, because it has been there from, for instance, from in our area, 1932. Imagine 1932, that was the first oil understanding. So in quality control and productions, automations, again, you know, how do you provide the data that is for the quality control and the productions automation? When we talk about the quality control, this has to do with the multiple disciplines that has been put into place. For instance, when we look at the ISO 9001, now to implement that with the manual and also putting those elements into AI, that brings you a much higher. Now, in supply and chain, it is as important as it is in the reservoir, is in the upstream and others. The route optimization, you know, to provide you with certain categories to be able to put your, for instance, barrel in the correct areas. Now, there are so many incidents happens of not knowing the progressive that is happening on the side, and also on the inventory itself. You know, in the oil and gas, the parts that are required for the production, whether it is in the power and out, are the most expensive parts. And these parts are developed based on the demand. So these are not like you go in the stock and off the shelves and bring them and within 2 weeks are delivered. These takes several months of manufacturing. Now, you have two problems here. You either bring enough spares and keep them and wish that they may come into an action one day, but most of the time you may not need them, and that's waste in the investment. You invested millions in something that you may not have needed it, or you take a risk of not ordering them and cross fingers that something will not happen. In both cases is a lose-lose. So with the inventory management systems and looking at the demand, and I will come to it in a minute, of understanding which parts are available based on the age, based on the quality, based on the history, those are provided with AI. And the energy management, these are also, and as I said, these are all examples of what has been implemented. I'm not talking about theories, by the way. So for instance, in renewable energy management and consumption reduction, with the sensors, you get a dashboard and those patterns of how much of, for instance, electricity and water is used in the factory, or, you know, we have also a shipyard that is connected to the oil because some of them are sent by the ship. but how much of it is used for that area. Now, most of the time, you found the electricity is used because it's a 24/7 operation, so you cannot stop it. In every warehouse and in every factory continuously. And imagine the consumption of electricity in those areas. But with the sensors and the devices used with the LLMs, we were able to reduce over 20% of the consumption of electricity and water in shape of ships cleaning by predicting the actions and having an autonomous actions on it. And of course, that also has effect on the renewable energies that we come to it and the maintenance scheduling. Maintenance scheduling is very interesting things. You look at any industry, how do you do your preventive maintenance? You tell me one area that you provide a maintenance, preventive maintenance based on the facts. It's all done based on the factory's recommendations. So you go, on the last 15 years, you're buying something from Honeywell or from any other Yokogawas. They're putting up their equipment, and they advise you, you're required to do every 6 months of maintenance or every 3 months. It's not based on anything. It's based on the recommendations. Now, that recommendation, of course, the factory is a win-win again. They can win by telling you, well, we told you, and you didn't buy, so it's out of warranty. Or they can tell you, you have to keep changing these devices regardless of the age, etc. But with the prediction maintenance that we use, the data on the AI, we have managed to increase and decrease. Some areas, for instance, from 6 months, we went to 1 year because of the condition of the equipment, because of the task, the risks, and that reduces your cost. And in some areas, we've managed periodically, depending on the summer and winter, because we have a summer, so you cannot do maintenance in summer and winter the same way. We reduce them from 6 months, for instance, to 3 months in certain periods, and etc. So that has increased the safety. It reduces the cost based on the shot. That applies to everything, by the way. It can apply to the aircraft, to the others. The same thing comes to the remote monitoring and the automated visual inspections. The visual inspections is related to what I just told you. For instance, the oil pipelines. You know, you have tens of kilometers of oil pipelines. And today in most countries, the security patrols sitting in the car and they go around with their camera looking if there is a deficiency or if there is a leakage in the flare, then they will act on it. Now, this is risky and inefficient. We've been able now, through either sensors and others, from one side to detect them, but also to be able to increase the monitoring in areas that are more vulnerable, that based on the quality, based on the steel age or the conditions that has been implemented in the past. Even in the workforce trainings, people send in the industry to trainings as they come. You know, so you and you and you go to the training because you haven't been to training for the past 2 years on the maintenance. Now, others, they may go to it because, you know, they're bored or they didn't have enough motivation. It's not based on any facts. Now, with collecting the data about the employees, the historical, by the way, people who go in the oil and gas, they get in young and they go out retired, so they don't go anywhere else. So you have so much of the data as well of the employees. And now, with the KPIs, with the industry, with their history, we were able to customize training per individuals. And not only that, but also the material that was created for the training, it was done by Gen AI. So the training is customized, prepared with the data on the periods, and there could be one person, it could be 10, if there are communities on that. So that's also related to the KPIs, related to the conditions of the equipment. And that has improved it so that it can be using virtual reality or augmented reality, but again, it's much linked to the AI. So again, we talked about the waste reductions and emission monitoring, We use that a lot, for instance, in aluminum manufacturing as well, on the ammunitions, the types of gases. On this specific one, we reached to 98.7% the accuracy. 98.7% the accuracy of identifying the emissions. I mean, there are things called green anode or baked anode in the aluminum. I mean, those people who worked in that area that are very critical to the production. So, what is the future of AI in the industrial field? I think that the future will be much focused on the large language models personalization. And what do I mean by that? Today, the generative AI is used loosely in every industry, and specifically in the oil and gas, to help employees to make better decisions and the industrial parts. But where were those large language models trained? Where were they done? They were done in certain industries that could be similar to yours or could be different. It could be in a different temperature, it could be in a different reservoir, or the oil distractions under the water, but there aren't parts that is related to you. So this is where we go to the closed large language models training, where we train the large language models based on the data that you have. So what it does, it goes to the closed LLMs, looks for the data that's specific to you, and if it cannot find it, then it will go to the open LLM. So when you go to it, it will look like Russians, oil manufacturing LLMs, and then if not, it will go to the next one. It will also have specifics to the employees and to the factories. Now, this personalization will go even to the individuals. As we go, it will go to the countrywide, closed LLMs, it will go to individuals. If you go to, for instance, using NVIDIA and others, it will cost you $15 million to do 2 rounds of training LLMs. $15 million. That's not a small amount. So now people, what tend to do, use the pre-built models, do the fine-tuning, and use the majority of that and train their own data, which will cost them probably 2% of the entire training on NVIDIA's or other GPUs. So as we get to the country level, we get to the manufacturing, and maybe LLMs specific to departments. So maybe to the department of the operations technology, maybe to the manufacturing. Each of them, they will have their own large language models. And then, of course, that will help to drive AI to the next part. Finally, what are the ethics related to AI in the industrial field? Now, we've seen European Union, for instance, came up with the EU Acts and the AI, or AI EU Acts. Now, that is something generic. First of all, it took them several years. And then when they wanted to come out with it, end of 2022, they just were surprised by generative AI. Oh, we didn't take that into consideration. So let's go back to the drawing board. Then they released it, I think, April this year. But even that is looking at mainly health and education, and it's very generic. So when we talk about the ethics in the industrial field, we can't use the general guidelines. We can't use the general governance for that. You have to be specifics to the industry. So the guidelines on the safeties, on the privacies related to it. The privacy of oil and gas is not the same as individuals' health records or and other parts of it. And the same things that will go, we will be more focused on that. One thing that we have to be wary of, and that's my final thoughts, the biggest field that is targeted for cybersecurity attackers is in oil and gas. There are many examples that the attacks that happens, if there's vicious and you want to harm the industry, or you want to do a ransomware, that's the area that they focus on. Now, the danger of that area is now no longer the cybersecurity attacks happening on the industry itself is the work of the hackers. It is the work of hackers enabled by AI. So imagine the difference in terms of analyzing the data, looking at the behavior. It will bring a question of, are we able, with the same tools, with the same people defending our networks, to defend the industry from the AI-driven cybersecurity attackers? The answer is, I don't think so. I don't think that will be even a balance between the two powers. So there is more emphasis that your network should be defended by AI cybersecurity tools. It will be very much, of course, even dangerous if they attack your core AI, because then they can take over everything else. So by that, my time is over, and thank you for listening to me.
Dr. Jassim Haji, thank you very much for your performance, and we have some questions from our audience. What do you think? Can AI technologies help to reduce energy resources consumption?
Can it reduce, sorry?
Reduce energy resources consumption.
Energy consumption. Yeah, as I mentioned earlier, especially we tried it in the electricity and water with the understanding of the elements. It can very much, we have a live examples that it reduces drastically in the power and other means. That means also using AI for understanding the generating energy tools like the powerhouses, etc.
Can you please share an example of implementing generative AI in Bahrain?
All those that I explained are driven by generative AI. But on the country level, we are also going to a Gen AI on the closed LLM. So in every ministry, in every industry, we are customizing Gen AI to meet that area. So in the health sector, in the schooling, the education, what we try to achieve, and we started in Bahrain, is, for instance, teacherless classes, where we use Gen AI to create syllabuses and interact with the students. We have certain lessons now as the trial, but hoping that that will be expanded. And for instance, in the education, we'll have more of Gen AI to be able to use that. We're using it in the health sector. We're hoping that when we get more of the data of individuals, we will have something like a Google Mid-Palm. So you have the history of the child and the family from the birth, from the ancestry, to be able to have even recommended Gen AI doctors rather than going to a random doctor and saying, I have a headache, and that it just prescribes you something different rather than having the entire history. So in education and health, these are the two important areas that we have to focus on.
If you don't mind, one more question. We have a lot, and this is very important. How can we ensure that manufacturers are not afraid of data leaks? Are fully autonomous models necessary for this?
I'm sorry, I have to ask you again.
How can we ensure that manufacturers are not afraid of data leaks? Are fully autonomous models necessary for this?
I mean, one example that I've given you, for instance, and the data leaks could be internal or external. And as I said, the external is even worse. With the power of AI, you don't know even somebody's monitoring you. It will be, in some cases, we've discovered that AI was used 2 years to be able to monitor the data, and then at the right time, at the right behavior, at the significant moment that was a failure from individual that the attack occurred. But there is other parts that is internal data leakage, which is as bad as the other ones. But that comes when I explained earlier on the quality control and the process. That generation AI also is being able to understand the behavior of the employees, the behavior of employees of leaking data or suspicious activities to be able to bring up through Gen AI an immediate response to that. And that is by probably changing even the policy with the understanding of the behavior that happens inside the organization or external organizations, or act as another virtual person interacting with those people to understand their intention. So those are also very focused.
Dr. Jassim Haji, thank you very much for your performance and for answering our questions.
Thank you very much.